Hello everybody. I'd like to talk about the Dunnett test. Dunnett test is one of the post hoc tests or one of the multiple comparison tests which is used in order to compare between the means for two different groups. I have talked in a previous video regarding the Dunnett test, but for the case of the equal sample size, in this video I'd like to talk about the same test, Dunnett test, but for the unequal sample sizes. So what we have here, the case we want to study is that we have a school admin wants to replace the traditional teaching method which is adopted by the teachers by a new one that comes up with better achievement for the students or better outcomes for the students. The outcomes of the different method have been recorded in below table. What is needed is to conduct the Dunnett test, considering that the traditional method as the control group, the value of the significant level is equal to 0.05. Here we have the records for teaching methods. Regarding the traditional one, we have here the records for the 10 replicates or 10 observation. Regarding to the second new method of teaching, which is method A, we have 8 observations, and we have here the records for this teaching method. And regarding the method B, we have 9 observations or 9 replicates, and these are the records for the method B. And the last teaching method, which is method C, we have 8 observations, and the records are inside this table. So by some simple statistics, we can get for the traditional method, the number of observations or the counts is 10. The sum of this method is 49. So simply the average can be calculated by dividing the sum of the observation by number of observations. And we get the variance for traditional method. We need to compare this method with 3 new methods. First, method A. Method A, we have 8 observations with total of 47. So the average is 5.88 and the variance is 2.41. Regarding the method B, we have 9 observations with total of 59 and the average is 6.56 and the variance is 2.78. And for the last method, which is method C, we have 8 observations with total of 60 and the average of this method is 7.50 and the variance is 2.29. Regarding the one-way ANOVA table and the result for the one-way ANOVA test, it is already here. As you notice here, the value of the statistic F or the calculated value of F, it's 4.39. It's greater than the value of the critical one. The critical value of F is 2.91. So simply the conclusion for this one-way ANOVA test is that there is a significant difference between the means of the groups for this study. As we said earlier, we have two formulas for the Dunnett's value, one for the equal sample size and the other for the unequal sample size. I have talked about the case for equal sample sizes in a previous video. You can return back. And regarding for this presentation, this is the formula we will adopt. So simply to calculate for the Dunnett's value, we should first determine what's called the T for Dunnett test. And this value of T is multiplied by the root square for the mean square within, or mean square for the error, multiplied by 1 over n sub I plus 1 over n sub j. I and j are two groups we need to compare between them. Notice that one of these two groups should be the control group. So this is the formula for the Dunnett's test for the unequal sample sizes. First of all, we should set for the null and the alternative hypothesis. First, we have the hypothesis related to the traditional method and the method A. We have two alternatives. We have two hypotheses, the null hypothesis, which state that there is no difference between the outcomes of the traditional method and the outcomes of the method A. The outcomes are the same. While for the alternative hypothesis, it states that the outcomes are not the same. They are not equal. One of the outcomes is greater than the other one. Notice that the sign here is unequal, so the test is two tails test. So the value of alpha, which is 0.05, will be divided into two equal values. Regarding the traditional method and method B, the same. We have the null hypothesis, which states that there is no difference between the two methods, the traditional one and the method B, while for the alternative one, it states that the means for the two methods are not the same. And for the last compare, or the comparison between the traditional method and method C, the null hypothesis states that the outcomes of the traditional method is equal to the outcomes of the method C. And the alternative states that they are not the same. So these are the null and the alternative hypothesis we need to test for this Dunnett test. Simply we can calculate for the absolute mean difference between the traditional method and the other methods. First of all, regarding the traditional method and method A, the absolute mean difference is equal to the absolute value of the average of the traditional method, which is the control group, minus the average of method A. The average of the traditional group or the control group is 4.90. It is inside the above table. And regarding the average for method A, it's 5.88. Again, it is inside the table. So the result is the difference between the two means is 0.98. regarding the traditional method and method B, the same way we calculate the absolute mean difference between these two means. We always compare regarding the control group, which is x bar t minus x bar b. X bar t is 4.90, while the mean for method B is 6.56. It is inside the table above. So the result is 1.66. And the third one is the traditional method and the method C. So the absolute value of x bar sub t, which is 4.90, minus x bar for method C, which is 7.50. So the result is 2.60. So we have here three differences in the groups or the different methods in comparison with the traditional one. We need to test for this absolute difference regarding the significance or non-significance. This is the formula for the Dunnett test in case of unequal sample sizes. Regarding the T for Dunnett test, we can simply determine the value of this T for Dunnett test by knowing three things. First of all, we need to know the significant level, and in our case it is 0.05, and we need to know k minus 1, and k here represents the number of groups, and we need to know the value of capital N minus k. Capital N here represent the total observation for all the four methods. So the value of alpha, which is the significant level, it is 0.05. And regarding k, it is number of groups. We have 4 groups. And for capital N, the total observation. If you count for the observations for the 4 methods, 10 plus 8 plus 9 plus 8, you will get 35. So capital N minus k is 35 minus 4, which is 31. Notice that capital N minus k, which is 31, it represents the value of the degree of freedom for the error, which is inside the one-way ANOVA table. And regarding the MSW inside the formula, it is the mean square within. Again, if we check for the one-way ANOVA table in the above, it is already 2.45. Mean square within, or the mean square for the error. So in order to get or to determine the value for the statistics T for the Dunnett test, we need to know alpha. We should know number of groups, and we should know the degree of freedom for the error. And regarding for small n sub I, it is the observation number in group I. This is the Dunnett's test table at 5% level of significant for two-tail comparison. Why we select the two-tail comparison? Because the alternative hypothesis is not a directional one. It states that the two means are not the same. It is non-directional hypothesis. So first of all, in order to get the value of t for Dunnett, we need to know the number of treatment means, excluding the control. So we have 3 new methods, and we should exclude the control one. So we select here 3. Regarding the column here, it represents the value of the degree of freedom for the error, which is capital N minus K. The degree of freedom for the error is 31. Here we don't have a 31. So we get the closer value. The closer value is 30. So the intersection between these two values is 2.47. So the value for t for the Dunnett test for a significant level of 0.05 for 2 tails, and number of treatment excluding the control group 3, and the degree of freedom for the error is 31. It is about 2.47. So this is the way how to determine the value of t for the Dunnett test. First of all, let's calculate the value of the Dunnett for the traditional method and method A. The value of the t for Dunnett, it's already about 2.47. So if we substitute in the formula, this is the value of the t for Dunnett. This is the value of the mean square within. It is 2.45 multiplied by 1 over 10. 10 is the size of the traditional group, which is the control 1. It is 10, and 1 plus 1 over 8, and 8 here is the number of observation for method A. It's 8. So if you proceed, you will get the value for Dunnett's to be 1.83. So simply we can compare this value, which is 1.83, and the value of the difference between the two means. The same way for the traditional method and method B. This is the formula for Dunnett's value. This is the value of the t for Dunnett test. And if you substitute, you will get 2.47, which is the t for Dunnett. This is the mean square within. This is the number of observation for the control group. And this is the number of observation for the method B. It's 9. It is inside the table here above. So simply you can get the value for the Dunnett's test to be 1.78. Again, we need to compare this value, which is 1.78, with the absolute difference between the averages of the method or traditional method and method B. The same way for the last comparison between the traditional method and method C. This is the formula for Dunnett's value. This is the value for t for the Dunnett test, it's about 2.47. If you substitute, you will get, this is the t, this is the mean square within, or the mean square for the error. This is the number of observation for the traditional method, which is the control one, and this is the number of observation for the method C, it's 8. So if you proceed, you will get the last value for the Dunnett's to be 1.83. So again, we need to compare this value for Dunnett's test, which is 1.83, with the absolute difference between method C and the traditional one. So here we have the conclusion for our question. We have three comparisons between the traditional one and the other methods. First, we have this pair, which is the traditional and method A. The absolute difference between the two means for the traditional method and method A is 0.98, and the calculated value for the Dunnett's test, it's 1.83. So the absolute difference is less than the value for the Dunnett's test. So we conclude here that there is no significance between the average for the traditional method and the average of method A. So in this case, we accept the null hypothesis, which states that the two methods, the traditional and method A, have the same means. Regarding the second comparison, which is between the traditional method and method B, the absolute difference between the two means is 1.66, and the value and the calculated value for the Dunnett's test is 1.78. So again, the absolute difference is less than the value for the Dunnett's. So we conclude that there is no significant difference between the two means. So in this case, again, we accept the null hypothesis, which states that the average for the traditional method is the same as the average for the method B. The last comparison, which is the comparison between the traditional method and method C, the absolute difference is 2.60, and the Dunnett's value is 1.83. Notice that the absolute difference is greater than the value for the calculated Dunnett's. So we conclude that there is a significant difference between the two means. So in this case, we reject the null hypothesis and accept the alternative one, which states that the average for the traditional method is not the same as the average for method C. In order to check which is better than the other, again we return back to the table in the above. The average for the traditional method is 4.90, while for method C it is 7.50. So we conclude that the average for method C is greater than the average for the traditional method. So as you see here in this table, we have only one significant difference, which is between the traditional method and method C, which means that method C is better than both method A and B. So we can simply, or the administration of the school can simply adopt the method C, which conclude that it will have a good achievement for the students of the school. So this is all about the Dunnett test. Thank you. If you have any comments, please write it down. Thank you.